This video will be going over the basics of Ohm's law as it appears in AC and DC circuit environments. The basic principle of Ohm's law is that it can be represented by this simple equation V equals IR, where V is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. Usually all of these values are the total in the circuit. So looking at a simple example of Ohm's law, using a 12-volt source voltage and a 600 ohm resistor, what is the current I flowing through this wire at the top? So taking our simple V equals IR, we are able to rearrange it to give I equals V on R, then substitute the values 12 and 600 to receive 20 milliamps as the total answer for the total circuit current. Ohm's law is also able to function in an AC circuit environment. However, it is represented now by V equals IZ. Z being the total impedance of the circuit, which is not the resistance. It is very slightly different, however, is basically the AC equivalent. Now, Z, the impedance, is given by R, the total of all resistors, plus JXL minus JXC. XL is the total reactance of all inductors given in ohms, and XC is the total reactance of capacitors also given in ohms, and J is represented just by the complex number √-1. Looking at a simple example of AC circuit Ohm's law, we can figure out the current once again. First, we must convert this 10 millihenries into ohms by using some simple AC circuit analysis that will be in a different video, and deduce that it is 3.77 ohms. Now, using the impedance formula, we are able to calculate that the total impedance of the circuit is 6.26 ohms with a phase shift of -37 degrees. Putting these values back into Ohm's law again, but with an AC environment, substituting in again, will give 1.6 amps with the same phase shift, as the voltage source does not have one. Thank you.